Hello, good morning dear students. Welcome to today's class. So today we are going to discuss this chapter called as gravitation. In this chapter we are going to discuss a very important law that is called as universal law of gravitation. Universal law of gravitation. Universal law of gravitation. Okay, so this law is proposed by Newton, and he said that if there are two bodies in the universe, wherever it may be in the universe, it can be anywhere in the universe. If there are two bodies, then these two bodies are always going to attract each other. Suppose if I take this pen and this duster, then these two bodies are always going to attract each other. So if there is attraction between these two bodies, then it means that there should be some force which is responsible for this attraction. Okay, this force is calculated by Newton. Okay, so how he calculated? So let's take an example. For example, I will take one body here. So this body is having mass m1 and this body is having mass m2, and this is the distance between these two bodies. Okay, this r is nothing but the distance between the centers of these two bodies. Okay, we have to take its distance from the center because we will consider the center of mass. That is different concept, we will explain in the later classes. So this is the distance between these two bodies. What Newton said is the force of attraction between these two bodies is directly proportional to product of their masses. This force is directly proportional to product of their masses. For example, if it is directly proportional, it means that if m1 or m2 or both, if any of them or both increases, then the force is going to increase. In the same way, if m1, m2 or both or any of them decreases, then the force is going to decrease. So this is the first thing what Newton said. After that he said this force is again inversely proportional to square of the distance between them. Inversely proportional to square of the distance between. We know when the two things or two quantities are inversely proportional, if one quantity increases, one quantity decreases. If one quantity decreases, one quantity increases. In the same way, if r, what is r? R is nothing but the distance between these two bodies. If the distance between these two bodies increases, then the force is going to decrease. Or else, if the distance between these two bodies decreases, that means if these two bodies come closer, means their distance is decreasing, and because these are inversely proportional, if it decreases, then it should increase. Means how much closer the bodies are, that much bigger the force will be. How much farther the bodies are, that much smaller the force will be. Okay, so this is the two things what Newton said. If I combine these two, that is F is proportional to, can I write m1 into m2 divided by r square? Yes. If I remove this proportionality sign, then we know in physics we have to always multiply with some constant. So that constant is taken as g. G m1 m2 by r square. And this g is called as universal gravitational constant. What is that? Universal gravitational constant. Gravitational constant. And this is constant, it will remain constant wherever you go into the universe. So this value, g value is 6.67 into 10 raised to minus 11. What about its unit? Let's take out its unit. See, if I take this equation, F is equals to g m1 m2 by r square. So if I take g one side and remaining terms one side, so F here, this is in the denominator, it will come to the numerator, Fr square divided by m1 into m2 is equals to g. Now substitute everyone's unit. So force is nothing but Newton, force is measured in Newton, R is nothing but distance, and this distance is measured in meter, so it is meter square, and divided by mass is measured in kg, again this is also kg, so again it is kg square. So this is G. So SI unit of G you can say Newton meter square per kg square. We have to remember one thing, that is gravitational force is always attractive in the nature, means wherever the two bodies are, these two bodies are going to always attract each other. So thank you very much. Thank you for watching this video. Take care.